Hello, my name is Sai Tedla, and this video will talk about my involvement with the DOLPI camera. A DOLPI camera is a camera that takes pictures based not only on the intensity and wavelength of light, but also based on its polarization. Essentially, it encodes information about the polarization of light within an image. So what is polarization and polarized light? In elementary physics, we learned that light from the sun vibrates in all orientations. However, when that light hits flat surfaces, the light is reflected in a specific orientation. This process is known as polarization. Human eyes are insensitive to polarization, but it is a useful property that gives more information about a scene. A polarizer is a filter that lets light from certain angles move through it. Polarized glasses have polarizers to prevent light that causes glare from entering your eyes. Previously, cameras that encoded polarization features have been very expensive, but this project, originally developed by David Prucci, has made it cheaper and the whole build can be made for around $100. This camera was built using a Raspberry Pi camera and a circuit that sent an AC signal to a polarizer with a liquid crystal panel. This AC signal changed the angle of the polarization, and the camera took a picture at 3 of these angles, 0 degrees, 45 degrees, and 90 degrees. It then overlaid all the photos with different colors to make a picture that encoded polarization. It was easy to make the polarization of the LCP to go to 0 degrees and 90 degrees, but 45 degrees is difficult because it requires a precise voltage. A calibration module was used to figure out the optimal voltage that allowed 45-degree light through the polarizer. The plot of the calibration is shown here. My contribution to this project was to find any issues with it and fix them, and also increase documentation on how to create this device. I tested with 2 types of polarizers to extend studies on this project. One of the polarizers was from a welding mask, and the other from 3D glasses. I learned that the welding glass photos were not nearly as vibrant as the 3D glass photos. 3D glasses could not go to the precise voltage for 45 degrees, and thus there were only 2 colors in the image. There are still many more iterations on how to make this camera better, but hopefully this polarization technology can be used in many ways in the future.